A user changes one number in a web address and sees another customer's invoice. The login worked. Encryption worked. The server still made the wrong security decision. That is the kind of failure the OWASP Top 10 helps teams recognize. The current released edition is OWASP Top 10:2025. OWASP calls it a standard awareness document for developers and web application security. It is not 10 individual bugs, and it is not a promise that every organization has the same risk order. OWASP combines contributed application testing data with exploitability, impact, coverage, and community judgment. Some weaknesses are easier to automate and measure than others. So treat the ranking as a strong industry signal, then apply your own threat model and business impact. Think of a web application as a small city. Access control is the locks and restricted doors. Cryptography protects valuables in transit and storage. Logging is the alarm system. Exceptional condition handling is how the city behaves during a power failure. The top 10 is the inspection map. A request crosses several components. The edge receives it. Authentication identifies a subject. Authorization checks an action and resource. Application logic validates input. Services and dependencies process it. A database returns data. Logging records the outcome. Security depends on the complete path, not one scanner. The 2025 edition adds software supply chain failures and mishandling of exceptional conditions. Server-side request forgery is consolidated into broken access control. Several categories moved or were renamed. Always confirm the edition before teaching, testing, or buying coverage. Broken access control remains number one. It appears when the server fails to enforce what a user or anonymous visitor may view or do. Examples include changing an object identifier, calling an administrator endpoint, crossing tenant boundaries, or bypassing a workflow step. Enforce authorization on the server for every object and action. Deny by default, scope database queries to the active tenant, minimize cross-origin access, invalidate authorization caches safely, and test the wrong user, role, tenant, object, and sequence, not only the happy path. Security misconfiguration rises to number 2. Risk appears through default accounts, unnecessary services, exposed diagnostics, permissive permissions, missing security headers, open cloud storage, verbose errors, or environments that drift away from the hardened baseline. Start with minimal hardened templates. Express configuration as code, remove samples and unused features, separate secrets from settings, automate validation, compare environments, and monitor drift. Production errors should help operators investigate without exposing stack traces, credentials, file paths, or sensitive records to users. Software supply chain failures broaden the old vulnerable components category. The risk includes dependencies, build tools, repositories, package registries, runners, signing services, deployment systems, and update channels. A secure codebase can still ship a compromised or vulnerable component. Minimize dependencies, use trusted sources, pin and verify versions where practical, isolate builds, protect release identities, generate an SBOM, sign artifacts, verify provenance, and preserve a path to patch or replace components quickly. Prioritize by reachability, exposure, and business impact, not scanner count alone. Cryptographic failures expose sensitive data when protection is missing, obsolete, incorrectly applied, or paired with weak key handling or randomness. Common problems include plaintext transport, poor certificate validation, hard-coded keys, weak password storage, predictable tokens, and sensitive data retained without a need. Classify data and avoid collecting what you do not need. Use maintained platform libraries and approved algorithms. Protect data in transit and at rest where appropriate. Store passwords with modern adaptive hashing. Separate keys from data, restrict their use, rotate them, and test recovery. Injection happens when untrusted input reaches an interpreter and becomes partly executable instructions. SQL injection is one example. Others involve document queries, operating system commands, templates, expressions, and browser contexts such as cross-site scripting. The precise defense depends on the interpreter. Use parameterized query APIs, safe templates, structured command interfaces, strict schemas, and contextual output encoding. Normalize carefully and reject invalid input. Run interpreters with least privilege. Input validation improves quality and reduces ambiguity, but it does not replace authorization or safe data code separation. Insecure design means the architecture or business logic lacks necessary controls. A flawless implementation can still be insecure if a password reset trusts weak evidence, a transfer has no limit, a tenant boundary is threat model important systems before coding. Identify assets, identities, data flows, trust changes, abuse paths, and failure modes. Convert them into requirements. authorization rules, transaction limits, separation of duties, rate controls, tenant isolation, secure recovery, and monitoring. Revisit the model when architecture or exposure changes. Authentication failures occur when login, enrollment, password reset, MFA, or session handling lets the system accept an invalid identity as legitimate. Weak passwords matter, but so do reusable sessions, unsafe recovery, credential stuffing, missing reauthentication, and failure to revoke access after compromise. Prefer phishing-resistant authentication for sensitive access. Rate limit and detect automated attempts without creating denial of service weaknesses. Protect enrollment and recovery, rotate sessions after privilege changes, set secure cookie attributes, reauthenticate important actions, and revoke active sessions after compromise, password reset, or account disablement. Software or data integrity failures appear when code or data is trusted without verifying its source or integrity. Examples include unsigned updates, unverified CI/CD artifacts, unsafe deserialization, unprotected pipeline configuration, and client-controlled data that the server treats as authoritative. Verify digital signatures and trusted identities, retain provenance, protect repositories and pipeline definitions, restrict who can change release workflows, and promote immutable artifacts. Avoid native object deserialization from untrusted sources. Use simple formats with strict schemas, reject unexpected types, and bind important state to server-side authority. Security logging and alerting failures delay detection, investigation, and response. Important events may be missing, incomplete, unprotected, impossible to correlate, retained for too little time, or never connected to an alert and accountable response process. Record authentication results, authorization denials, privilege changes, administrative actions, validation failures, integrity checks, and high-value business events. Include consistent time and correlation identifiers. Never log passwords, private keys, or reusable session secrets. Protect logs, test alerts, and rehearse the response rulebook. Mishandling of exceptional conditions is new in the 2025 list. Systems can crash, leak internal detail, enter invalid states, repeat sensitive operations, exhaust resources, or fail open when inputs are malformed or dependencies time out. Attackers deliberately explore those edges. Define safe outcomes for invalid input, timeouts, retries, partial success, unavailable dependencies, and resource pressure. Bound recursion, memory, queues, request size, and retries. Make sensitive operations idempotent. Roll back incomplete transactions, hide internal detail, fail closed for security decisions, and alert on repeated abnormal states. The top 10 is best for awareness, training, risk conversations, and an initial review. It is intentionally limited. For engineering depth, combine it with other OWASP projects rather than stretching one document beyond its purpose. Use the application security verification standard when you need detailed, testable security requirements for design, development, procurement, or assessment. ASVS helps turn prevent broken access control into concrete verification objectives. Select the appropriate assurance depth based on application risk. Use the Web Security Testing Guide when authorized testers need structured ideas for evaluating web applications. It supports test planning and manual reasoning. It is not permission to test systems you do not own or lack written authorization to assess. Use the software assurance maturity model when the question is organizational. How consistently do teams govern, design, build, verify, and operate software security? SAMM helps plan improvements across people and process. A mature program still uses application-specific threat models and technical verification. Consider a fictional retailer called ShopSpring. A customer reviews a cart, applies a discount, pays, and opens the order afterward. The browser calls an API, services check identity and price rules, dependencies process payment, a database stores the order, and telemetry records security decisions. In the broken version, the order endpoint trusts a customer-supplied order number without checking ownership. The discount service evaluates a raw expression. A package update is accepted without provenance. Repeated authorization denials are logged locally but never alerted. 4 categories now reinforce one attack path. The safer version derives customer identity from the validated session, scopes every order query to that customer, parses discounts as typed data, deploys a signed artifact with verified provenance, and sends repeated denials into a tested alert. Error paths roll back payment and order state together. Test the correct purchase, then the wrong customer, changed order identifier, malformed discount, duplicate request, expired session, and signed artifact, payment timeout, database failure, and missing alert destination. Confirm both the user visible result and the protected evidence available to responders. Use the top 10 to teach and start conversations. Use threat modeling for the application's unique assets and abuse paths. Use ASVS to specify verifiable controls. Use WSTG to organize authorized testing. Use SAMM to improve the security program. Use telemetry and incident learning to close the loop. A scanner may find some injection, configuration, dependency, or cryptographic problems. It cannot prove that every business rule, recovery path, tenant boundary, exceptional state, and alert works correctly. Ask what evidence each tool produces, where it has context, and what remains for human review. Blocking one request pattern at the edge may buy time, but it does not repair missing server authorization or unsafe query construction. Fix the root cause, add negative regression tests, search for similar patterns, update reusable controls, and verify that detection and response also improve. Teams often stop at build success. Production introduces real identities, data volume, dependency outages, configuration drift, and abuse. Monitor important decisions, preserve evidence, test alerts, rehearse containment and recovery, and feed incidents back into architecture, requirements, tests, and release controls. Fact-check immediately before scheduling. Confirm that 2025 remains the current released edition and that category names and guidance have not changed. This video intentionally avoids unstable incidence figures because some OWASP introduction and detail pages currently differ. Use the official category pages as the publication baseline. Broken access control, security misconfiguration, software supply chain failures, cryptographic failures, injection, insecure design, authentication failures, software or data integrity failures, security logging and alerting failures, mishandling of exceptional conditions. 10 categories connected across one application system. Use the OWASP Top 10 as the shared map. Then threat model your application, define verifiable requirements, test authorized systems, protect the delivery chain, monitor production, and learn from failure. The goal is not to claim coverage. The goal is to make safer decisions repeatedly. Copyright 2026 CipherVibe.